Okay, for this lesson, we're going to look at linear equations and graphing linear equations. The first section is on linear equations and intercepts. A linear equation is an equation that forms a line when it's graphed. And you can see the word line right in the word linear. So we know we're going to graph a line. The standard form of a linear equation is ax plus by equals c. C is called the constant term because it's never changing. There's nothing that's multiplied by it. Ax and by are the variable terms, and a and b would be the coefficients on the variable terms. So an example would be something like 2x plus 3y equals 4. That would be an equation in the standard form. In the examples, it wants us to determine whether each equation is a linear equation and write the equation in standard form. So for A, I can see that it's a linear equation because I have two variable terms. I have an x term and I have a y term. Now you don't necessarily have to have two. It depends on the line itself, but we do have an x to the first and a y to the first term. And I see that I have a constant term. So I'm going to say that that is a linear equation. And then I want to put it in the form, in standard form, which is ax plus by equals c. So I want the x's and the y's on the same side together. So I would add 3x to both sides to get them on the same side. And that would give me 3x plus y equals 4. And even though you don't see a b term, that's actually 1 there. So yes, it's linear, and here's my equation in standard form. Now on b, I would say that this one is not a linear equation because even though I have an x term, I have a term with both x and y in it. And you don't see that in standard form. So not linear. And then in C, again, I have a y term, but for my x term, it's x squared, and I don't have an x squared in the linear equation. So this one is not linear either. We're going to look at some graphs of linear equations. It says when graphing a linear equation, the graph can intersect the x-axis and the y-axis. You can also have one where it intersects only the x-axis and only the y-axis. These intersections on the graph are called the x-intercept, which is at coordinates a, 0, so some number and 0. And the y-intercept is at 0b, so 0 and some number. You can see in the first graph that I have both an x-intercept and a y-intercept here. And so the x-intercept is at -4, 0, and the y-intercept is at 0, 6. So that's a very common one that you'll see. Then we have an equation with just a y-intercept. And so it is a linear equation, but the equation is y equals -2. The x would just have a multiplier of 0, so we don't show that one. And so this is a horizontal line. And then our third example here is one that only has an x-intercept, and its equation is x equals 3 because it goes through 3 on the x-axis, and it is a vertical line. So horizontal lines will have the equation y equals b, and vertical lines will have the equation x equals a. Example 2, find the intercepts from a graph. Find the x and y intercepts of the line graphed at the right. So along the x-axis, right here, I see that I have a place where the line crosses the x-axis at 20. So that coordinate is 20, 0. That's my x intercept. And then I see that I have On the y-axis, the line crosses the x-axis at 30. That coordinate is 0, 30, and that's my y-intercept. In the second graph, I've got more of a graph that you would see in real life where you're actually given some information, but we can still just find the x and y intercept for that. Now in this one we have a horizontal line, and we saw in the previous examples that when you have a horizontal line, you'll only have one intercept, and here's my line, and it's crossing the y-axis at 150. So the coordinate, we only have a y-intercept, and the coordinate is at 0, 150. Example 3, find the intercepts from a table. A swimming pool is being drained at a rate of 720 gallons per hour. The table shows the function relating the volume of water in a pool and the time and hours that the pool has been draining. And so we have a T-chart there that gives our draining a pool. Our x-coordinate is the time and our y-coordinate is the volume. And it says find the x and y intercepts. And we know that an x-intercept has coordinates of a 0, which means we have a y-coordinate of 0. So then we have a corresponding x-coordinate. So in this case, 14, 0 would be the x-intercept. Then we have our y-intercept, and that takes the form 0b. So we're looking for a 0 in our x-coordinate, which is going to happen right here. So the y-intercept would be at 0, 10,000, 10,080. Part B, it says describe what the intercept means in this situation. So this is a graph of the T-chart and shows what the pool draining would look like. And so there's our y-intercept. And here's our x-intercept. And we just want to tell what that means. So the x-intercept, we'll notice the x-coordinate is the time and the y-coordinate is the volume of water. So if our our x-intercept is 14, 0, it says at time 14 hours, there is 0 water in the pool, which means it's fully drained. The y-intercept that has coordinate 0, 10,080 gives me time 0. So that's before we started draining it. So at time 0 hours, there is 10,080 gallons in the pool. So that's how much water we have before we start draining. So 10,080 gallons before we start draining the pool, and it takes 14 hours to do that. Graphing linear equations. So there's several ways to do this. One of the ways is to graph equations using your intercepts, which is probably one of the easiest ways by far. You need a minimum of 2 points to graph a line. So that's what we're going to get. And you'll notice that the x-intercept is a point and the y-intercept is a point. So we could use these 2 points of our linear equation to graph the equation. We have, it says a graph using intercepts. We're going to graph the equation 2x plus 4y equals 16 by using the x and y intercepts. The x-intercept, again, the form of that is a 0. So what we really want to do is figure out what is a going to be. So this would be our x and this would be our y. We don't know what the x is, but we do know that the y is 0. So what I would want to do is take my equation and substitute 0 in for y, and then solve for x. And that would tell me where along the x-axis I need to place a point. So 2x, 4 times 0 is 0. So I have 2x equals 16. And then I would divide by 2. And that tells me that x is 8. So I actually have an x-intercept at 8, 0. So let's see, it's going to be about right here. It's a little bit off the graph, but that's okay. And then I'm going to do this just kind of the opposite for the y-intercept. The y-intercept is at point 0b, which tells me that the x-coordinate is 0 and the y-coordinate is the thing that we need to find. So what is b? And that's where we're going to graph a point on the y-axis. So now I'm replacing x with 0, and I'm going to solve for y. So this gives me 0 plus 4y, so just 4y equal to 16. And when you divide by 4, you get y equals 4. So I know on the y-axis, I want to put a point at 4 on the y-axis. So there are my 2 points. Now all I have to do is get a straight line. Oh, did not see that coming, kids. Let's try that again. So I'm going to draw a line through my 2 points, the best that I can. And that's going to be the graph of my equation, just by substituting 0 in for x and y to get my intercepts. For 4b, we'll do the same thing. So we're going to do the x-intercept by putting 0 in for y. And we're going to do the y-intercept by putting 0 in for b. So for the x-intercept, that's going to be 0 equals negative x minus 5. Then I want to add 5 to both sides to get x, solve for x. And then divide by negative 1. So that tells me that x equals negative 5. So that means I want a point where x is negative 5, right there. And then for the y, I'm going to substitute 0 in for x. And that gives me y equals negative 5. So on the y-axis, I want to point at negative 5. And then we're ready to draw our line through the 2 points. So that's how you use the x and y intercept to graph a line. It says it's possible to have an equation with only one intercept, either an x-intercept or a y-intercept. If I have an x-intercept only, then I'm going to have a vertical line. If I have a y-intercept only, I'm going to have a horizontal line. Another way to graph an equation is to make a t-chart or make a table of values. And so when we do this, really typically we pick values for x, And then we figure out what the corresponding value is for y, and we'll plot that ordered pair. So you can pick anything you want to for x. I like to keep it small, and I also want to keep it on my graph. So we're looking at only values probably between -6 and 6 there. I always like to pick a negative. So, and I know I'm going to put a value in for x there. So I want it to somehow work with 1/3 easily. And I see I have a denominator of 3. And if you just remember that denominator means divide, whatever I pick for x, I would really like to be able to divide it by 3. So I'm going to pick -3 because I know I can divide it by 3. I'm also going to pick 0 because that's always a really easy one. Then I'm going to pick a +3 and a +6 to go with my values. And then I can work it out a little bit. So I have 1/3 times -3 plus 2. 1/3 times -3 is -1, plus 2 is 1. So now I have an ordered pair of -3, 1 that I can plot. And I'm going to go through the same process for the other numbers. So 1/3 times 0 plus 2 is 2. 1/3 times 3 plus 2, well, that's equivalent to 1 plus 2, which is 3. And then I'm going to do 1/3 times 6 plus 2, which is equivalent to 2 plus 2, which is 4. Now, it's kind of coincidence that my outcome was 1, 2, 3, 4. That's just special for this equation. So it's not always going to be that way. But my second ordered pair would be 0, 2, then 3, 3, and then 6, 4. And I can plot those points on my coordinate plane and draw a line through them. So -3, 1 would be right here. So -3 on the x-axis, and then 1 on the y, and then their intersection. 0, 2 would be here, 3, 3, and 6, 4, and then I can draw a line through my points. And there's the equation of, or there's the graph of my equation. Okay, so we looked at using x and y intercept, and we looked at making a table. The next one we're going to look at is using slope-intercept form. So that's exactly what we're going to have. We're going to have a slope, and the intercept refers to the y-intercept. To find slope, you need 2 points, and here's the equation for slope. So slope, you're going to take the difference of the y's over the difference of the x's. Slope-intercept form looks like y equals mx plus b. The x and y in the equation are all of the x and y coordinates that satisfy the equation. The m is your slope, and we usually think that as rise over run. And the b is your y-intercept, which has coordinates 0, b. These are just the instructions that you can go through to graph using slope-intercept. So it says locate the y-intercept on the y-axis and graph that point. So we're going to put that point 0b in. From the y-intercept, you want to follow the directions of the slope. Move up or down the number of units in the numerator. So up if it's a positive and down if it's a negative. And right or left the number of units in the denominator. So right if it's positive, left if it's negative. That's going to give you a second point that you're going to put on the graph. And now we talked about only needing really 2 points to draw a line, and now we have our 2 points, and that's the graph of your equation. But before we get started, we do want to take our equation and make sure it's in slope-intercept form, which is y equals mx plus b. So that just means that we need to solve for y. We're going to take that equation, we're going to get y all by itself. So my original equation is 3x plus 2y equals 6. So the first thing I would want to do is subtract 3x. So that would leave me 2y on the left. And you'll notice in the equation, slope-intercept equation, that the x term comes before the constant term. So I want to write it that way. I'm going to say minus 3x plus 6. And then I'm going to divide by 2 because I still want to get that y by itself. So I divide both sides by 2. And that gives me y equals, and what I actually want to do is put that denominator of 2 there under both terms. So minus 3x over 2 plus 6 over 2. And then you can reduce it if you're able to, which that would be y equals negative 3 halves x plus 3. Then I'm actually going to go ahead and identify the parts. If this is y equals mx plus b, then my slope is negative 3 over 2, and b is 3. And those are the parts that I need. So I'm going to take, and according to the instructions, I'm going to locate the y-intercept, the b, on the y-axis and graph the point. And b is 3 there. So I'm going to put a point 3 on the y-axis. Then from that point, I'm going to take the slope and I'm going to follow the directions to the next point. It says my slope was negative 3 halves. And the directions say that my numerator is going to tell me to go up or down. And in this case, it's going to tell me to go down because it's negative. I'm going to go down 3 spaces from the intercept. So down 3. And then my denominator is positive. That tells me to go right 2 units. So I went down 3, right 2. And that's my second point then. So the arrows, the path that I followed, that's not part of the graph, but it's telling me how to get to that second point. And now I have 2 points to draw a line through. And that's the graph of my equation. We'll put some little arrows there because it is a line. Okay, one last example is using point slope form. And so we have a point and we have a slope. And point slope form is going to look like this. It's going to be y minus y1 equals m times x minus x1. So we'll be given a point, or we'll have a point x1, y1, and we'll have a slope m, and it says insert the values into the point slope form and rewrite the equation in slope-intercept form. So we're not actually graphing with point slope form. We need to rewrite it in slope-intercept form, and then we're going to go back and follow those same instructions that we had for slope-intercept form. It says write an example in point slope form for the line that passes through each point with the given slope, then graph the equation. So our point is 5, 3. And so that's going to be our x1, y1, and then we have m for our slope. The form of our equation in point slope form is y minus y1 equals m times x minus x1. This just gives us a way to start an equation if we're given a point and a slope. And we don't know what the y-intercept is. So the regular y and the regular x, that just represents all of the points that satisfy the equation. What we're really concerned about when we're doing substitution is the x1, x2. So this would give me y minus y1, which is 3, equals m, the slope, which is 7, times x minus x1, which is 5 in this case. And now, so I've put it in point slope form. I just want to now transfer it to slope intercept form. Which is y equals mx plus b. That just means I need to simplify it and solve for y. So I'm going to go back to the equation I have, y minus 3, and I can distribute the 7. So I don't have any parentheses in the slope-intercept form. So that's 7x minus 35. And I'm almost done. I'm going to add 3 to get the y by itself. Y equals 7x minus 32. That gives me a slope of 7. And I'm going to do 7 over 1 because I need complete direction. So go ahead and make that a fraction. And then b is negative 32. Now, if I go and use the intercept and the slope to graph this, you can see that I don't have negative 32 on there. So I need to kind of determine about where I want to put my graph. And I'm just going to count the little boxes here. I've got 2, 4, 6, 8, 10, 12. So if I go by about 3s, that should get me on the graph. Okay. So if I take each box and I go by 3, I'll let each box be 3s. So this would be 3 and then 6 and so forth. I have 9, 12, 16, 16, hang on, I didn't go by 3s. Let me try that again. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33. That's going to get me down here at about negative 32. And then I'm going to use my slope to give me a second point from there. And that says go up 7 and go to the right 1. So I'm going to go up 7. Right here would be about 7. And then over 1 would be about right there. It is really close. It's just barely going over. Have a point right there. Do it in red so we can see it a little bit better. So here's one point and here's another point, and I'm going to draw a line through those. And there's my equation. Okay, that's the end of the lesson. There are also some practice problems for you to work out and some additional videos to view.